Right, today we're going to talk about how living things are classified. And first we're going to start with the history of classification and talk about Aristotle, who lived hundreds of years ago. And Aristotle, his belief was that any organism could be classified as either a plant or an animal. And back in his time, you have to think about the tools that they didn't have. They didn't have microscopes, they didn't have magnifying glasses, they couldn't see bacteria, and they couldn't really tell the difference between fungus and different types of plants. So it was pretty common and understandable that they placed groups in either plant or animal groups. Linnaeus came hundreds of years later, as you can see by his picture and what he looks like. And he said that the classification system was based on looking for organisms with similar structures. So physical structures, possible structures inside of them, ways that they react to things. So that's how they grouped organisms. So we eventually decided on the following classification system, and this classification system still holds today. And that is the kingdom, phylum, class, order, family, genus, species. So kingdom is the largest group and the least specific group. So these are like animals. There's an animal kingdom. There's a plant kingdom. There's a fungi kingdom. There's a protist kingdom. And as you go down, it gets more and more specific, all the way to species. And species always has two names. The genus and the species name. And we'll see that in just a second. So how will you remember the order of this classification? The 6 kingdoms are plants, animals, protists, fungi, archaebacteria, and eubacteria. And remember, are these the most specific or the least specific? They're the least specific. They're the most broad of all the levels of classification. So, a scientific name. This is really important when classifying animals. What do you call a soda? Do you call it soda, a Coke, something different? Everybody calls this something different, and that's kind of the issue with calling animals names. That's why we need scientific names, so that everybody has a common name to call the animal, plant, or other type of organism. And that's when we came up with binomial nomenclature. If you'll see, the bi means what? It means two. And nomen kind of has to do with names. So binomial nomenclature is a 2-word naming system that's used to name species of organisms. So here's some examples. Here you have a lion, and here you have a cat. And you'll see that the genus name is the same because they are related, but the species name right here is different. This is Leo and this is Domesticus, and the language of this is Latin, in case you're wondering. So they decided on Latin. So uses of scientific names. Why do we even bother with scientific names? First of all, they help avoid mistakes. They give descriptive information about the species. So when they chose the Latin name, they didn't just randomly choose a Latin word. They actually gave the word to the organism that tells a little bit about it. And they allow the information to be organized. Dichotomous key is another way to classify animals and plants and organisms. It's a detailed list of identifying characteristics that includes the scientific names. So pretty much a dichotomous key is a way to find out the scientific name of an organism. And here's an example of what a dichotomous key could look like. So we have number 1, 2, 3. So all of these are numbered, but we don't have the name for them. So what you do is you pick one. So we will pick number 1 right here. And we will go through and start at number 1. And we'll decide, is it an organism with 2 or 4 legs, or an organism without 2 or 4 legs? And obviously this organism has 4 legs, so we're going to go to 2. and we need to decide, is this an organism without wings or an organism with wings? Obviously, this organism does not have wings, so the Latin name is, or the scientific name is Canis familiaris, or a dog. All right, let's do number 7. Is this an organism with 2 or 4 functional legs or an organism without 2 or 4 functional legs? This organism doesn't have legs, so we're going to go to 3. Is the organism unicellular or is the organism multicellular? I can tell you right now it's multicellular, so we're going to go to 5. And then you have to decide, is the organism heterotrophic or is the organism autotrophic? So the organism is actually heterotrophic, so we're going to go to 6. And does the organism live in the oceans or does it live on land? And it does live on land, and we find out the scientific name and the common name, which is the king cobra. So that's how dichotomous keys works. And we're going to watch a quick video that explains it a little better.
There's a lot of birds in our world, and if you were asked to identify a bird based on its characteristics, you could probably do it. We could probably name the hummingbird, the owl, the duck, and the penguin based on its features. But if you were asked to name these birds using their scientific name, the task wouldn't be so easy. You wouldn't know the scientific name of these birds just by looking at them. Scientists have figured out a way to make a chart to help you better identify birds based on their characteristics. The chart is called a dichotomous key. Reading a dichotomous key is easy. Take a look at the hummingbird. To use a dichotomous key, start at number 1. At number 1, it's asking us to observe the feet of the bird. A hummingbird does not have webbed feet, so we'll go to step 3. Step 3 has us examine the bird's tufts. Our bird does not have tufts. We just figured out the scientific name. Let's try the dichotomous key again with a different bird. This time we have the penguin. Start at number 1. Our bird has webbed feet, so we're going to have to go to step 2. Step 2 has us count the number of toes. A penguin has 4 toes. We just figured out the scientific name of the penguin. Using the same chart, we can figure out the scientific name of the duck. Starting at number 1, we see our bird has webbed feet, so we'll go to step 2. We have to count the toes. The duck has 3. We just figured out the scientific name again. Lastly, an owl. Always start at number 1 on the dichotomous key and look at the features of the organism you're trying to identify. Our bird has tufts. This is its dichotomous key's scientific name. Dichotomous keys, charts that scientists use to figure out the scientific name of organisms or to help identify footprints. Dichotomous.
All right, so that is all the notes today for classifying different organisms. Please write down any questions that you have, and we will talk about this and do activities with this tomorrow.